This video presentation is all about distribution transformers. The purpose of a distribution transformer is to reduce the primary voltage of the electric distribution system to the utilization voltage serving the customer. Or, in other words, it converts high voltage electricity to lower homes and businesses. Distribution transformer is a static device constructed with two or more windings used to transfer alternating current electric power by electromagnetic induction from one circuit to another at the same frequency but with different value of voltage and current. The basic principle of operation of a distribution transformer consists of a primary winding and secondary winding wound in a laminated steel core. If the load is disconnected from the secondary winding of the transformer and the high voltage is applied to the primary winding of the transformer, a magnetizing current will flow in the primary winding. If we assume the resistance of the primary winding is small, which is usually true, the current is limited by the counter voltage of the self-induction induced in the highly inductive primary winding. A distribution transformer is either single-phase or three-phase, depending on its connections. A single-phase transformer are designed to step down a single alternating current from one voltage to another. It consists of a primary winding and a secondary winding wound on a laminated steel core. Single-phase distribution is used when loads are mostly lighting and heating with few large electric motors. Distribution transformers in three-phase are designed with three sets of primary and secondary windings and wound around one leg of an iron core assembly. Essentially, it looks like three single-phase transformers sharing a joined core. The primary and secondary winding will be connected in either a Y to Y, delta to delta, or delta to Y or open delta configuration, or a combination of the two to form a complete unit. In an open delta connection, one of the transformer from a delta connection is removed. The remaining two transformers are said to be in an open delta connection. This can be done when the remaining two transformers will still transform the voltages in all three phases and supply power to all three phases of the secondary mains. The open delta connection is often used where an increase in load is anticipated. The third unit is added when the load grows to the point at which it exceeds the capacity of the two transformers. Furthermore, if one transformer of the three-phase bank should become defective, the defective transformer can be removed and the remaining two transformers continue to render service to at least part of the load. Another connection is the Y-to-Y configuration, wherein the three single-phase transformers are connected in Y such that its line current is equal to its phase current. Another connection is the delta-to-delta configuration, wherein the three single-phase transformers are connected in a triangle form and its phase voltage is equal to its line-to-line voltage. A delta-to-Y configuration is a connection of the transformers wherein the one is in Y form and the other is in delta. A single-phase distribution transformer may be connected in series, parallel, series and center-tapped connection. A series-connected transformer is a transformer wherein the inductance and the secondary winding are connected in series. In a series and center-tapped connected transformer, the inductance in the secondary winding are connected in series, but a grounding is tapped in the center of them. In a parallel connected transformer, the inductance in the secondary winding are connected in parallel. In connecting transformers, it is important to know the polarity of the transformer terminals or LEDs. In building transformers in the factory, the ends of the windings can be so connected to the LEDs extending out through the case that the flow of current in the secondary terminal with respect to the corresponding primary terminal is in the same direction or in the opposite direction. When the current flows in the same direction to the two adjacent primary and secondary terminals, the polarity of the transformer is said to be subtractive. And when current flows in opposite directions, the polarity is said to be additive. Let us now discuss the different types of distribution transformers. According to mounting, a pole-mounted transformers. This transformer is a typical distribution transformer installation with a transformer bolted directly to the pole. The unit is equipped with a surge arrestor, a low-voltage circuit breaker, and an overload warning light. A partial range current limiting fuse is mounted on the primary bushing, connecting it in series with a high voltage winding to prevent a violent failure of the transformer if an internal fault develops. A pad-mounted transformers. These transformers are used with underground systems. This may be in a three-phase or in a single-phase connection. A three-phase pad-mounted transformers are used for commercial installations, while a single-phase pad-mounted transformers are used for underground residential installations. A volt-type distribution transformers are installed for commercial customers where adequate space is not available for pad-mounted transformers. It may be installed in a vault under a sidewalk or in a building. They are often used in underground electric network areas. A submersible distribution transformers are used in some underground systems installed in residential areas, but corrosion problems and the high cost of installation have minimized the use of submersible transformers. A network distribution transformer are always connected in three-phase, and these transformers are commonly used in commercial buildings located underground. Distribution transformers according to protection. A conventional distribution transformers. These transformers consist only a case containing the transformer unit with their protective devices. A completely self-protected transformers are transformers with a weak link or primary protective fuse link, which are mounted inside the tank with the transformer unit, and also there are two circuit breakers for protection on the secondary side of the transformer. Distribution transformers according to insulation. A liquid immersed transformers. These transformers are also called the self-cooled transformers. In these transformers, the core and the windings are immersed in some insulating liquid and enclosed in a metal tank. The liquid in addition provides some of the required insulation between the windings. It carries the heat from the core and windings to the surface of the tank. The heat is then removed into the surrounding atmosphere by natural convection of the surrounding air and by radiation from the tank. A dry-type transformers are transformers which are cooled by normal air ventilation. Unlike other transformers, it is voltage changing, usually meaning they are stepping down or down voltage, and are also isolation devices that are air-cooled rather than liquid-cooled. Some of the dry-type transformers are sealed within an inner cast atmosphere, and others are cast coil design. Distribution transformers according to construction. A core-type transformers. The core is in the form of a rectangular frame with the coils placed in the two vertical sides. The coils are cylindrical and relatively long. A shell-type transformers, the core surrounds the coils instead of the coil surrounds the core. The coils in the shell type are generally flat instead of cylindrical. The primary and secondary coils are alternated. For latest update about transformers, there are new forms of transformers now. A hybrid transformers. These transformers are high-efficiency power transformer that is capable of reducing harmonics, improving imbalance, and transforming voltage. These are multi-function transformers, an eco-friendly product with a dry TR design, which has lesser noise and loss, and are typically used in radar systems, data processing equipment, telecommunication systems, test control, and measuring systems. Anamorphous metal transformers. These transformers are used for medium power distribution. These are ultra-low loss design solution which reduces no-load losses and reduces harmonics. And the most advantage of these transformers is the significant energy and monetary savings. Superconductor transformers. These transformers are used for ultra-high power transmission. Its efficiency is approximately 98.5%, which reduces no-load losses in a factor of 3 and increases core cost by a factor of 2. Its advantage would be it needs heat refrigeration for heat removal.